Welcome to If Only You Knew, where each week we take a deep dive into the careers and experiences of people from different backgrounds, cultures, countries, and ages to discuss pivotal moments in their lives and the lessons they have learnt along the way.
If they told people the truth, they wouldn't last very long.
Whether you're a school student in an established career, mapping your academic pathway, searching for the perfect career, looking to change careers, or just plain curious, then this podcast is for you. I'm your host, Christy McCormack, and I want to ask you, what would you do differently if only you knew? With me today is Stefan Tschirren. Stefan is the Principal Structural Engineer of STS Structural Engineering Consultancy and the Queensland Chapter Chairman of the National Association of Steel Framed Housing. Welcome, Stefan, and thanks for joining me today.
Thanks, Christy. Thanks for having me with you.
Okay, so we're going to be talking everything engineering today. And to be an engineer, you obviously need qualifications from university. And you completed your Bachelor of Engineering in Civil and Construction Engineering in 2004. Did you go straight from school into university, or did you have a bit of a gap in between?
I did actually go straight into university, but it's probably a little bit of a unique case with myself. And also just to add to your talk, everything engineering, that's a very broad term. So that's one of the things I want to actually highlight a little bit here, because engineering is one of those words that gets thrown around, and it really can apply to a whole bunch of things. So my journey was pretty direct, to be completely honest. It was quite streamlined, straight from high school directly to uni, and then from uni directly to work without much of a break. It's something which really accelerated my career, but at the same time, it didn't give me much of a chance to have a break and have time for myself. So there's pros and cons to everything, I believe.
So when you were in high school, did you always sort of plan to become an engineer? How did your school sort of subjects influence the career path that you chose?
The engineering only really came into my head towards grade 11 and 12. Before that, I didn't really even know an engineer existed. The catalyst behind my thinking process was the renovations that we were doing at home. So my dad's very hands-on. He's a plumber and gas fitter. My mum's more of a book-smart person. She's an accountant, bookkeeper. So I had exposures to kind of the both sides of the spectrum, so to speak, the manual labor side and the very technical side. And I never knew exactly which path would suit me. When we were extending our house, we were doing a fairly major renovation, a double-story extension, and being in Perth, it was all concrete and brick and fairly heavy construction. I at the time had been playing around with a lot of graphic design and CAD work and a little bit of 3D animation, because that was kind of a technical but cool artsy space to be in at the time. And then when we did this extension, I realized that there was an architect that had to do the drawings, but then on top of that, an engineer got called on board to provide technical advice on whether the building could actually stay up. And I asked the question, what does that guy actually do? Why do we need an engineer? And it kind of merged both worlds, the practical building aspect of being able to touch and feel what you're actually producing, as well as the numerical numbers and math and physics aspect of figuring out the science behind what you're actually building. So that kind of sparked a little interest in me, and I wasn't completely convinced that that was something that I actually wanted to pursue, but it was interesting enough for me to tailor my final year electives in high school towards. So I basically picked the physics and chemistry and upper maths courses in high school. But then to balance that, I also did graphic design, and to kind of still pursue the things that I was using as a hobby at the time. And it kind of just flowed on from there. So it wasn't something that I was aiming towards. It was something that kind of landed in my perspective. It's probably the best way to put it. Landed in my field of view at that kind of complemented my hobbies and interests at the time.
So when you talk about, you use CAD programs and you did graphic design at school, was that something that you did all through the school? Because I know I went to high school around the same time as you, and we didn't have those sorts of subjects and programs available at my high school. So was your was your school sort of really supportive in that sort of, I suppose, leaning towards the professional careers?
Yeah, I think so. It was a public school, but at the same time, I think my year was one of the first in a lot of things. We had a computer programming class, for instance, which was a new thing, which was introduced. We had actual computer-aided drawing, so CAD came in as a kind of an extra thing linked onto the technical drawing. So when I started technical drawing, which it was pen and or pencil and paper on a drafting table, I did that for a few years in high school. But then in the last 2 years, about 50% of the time moved onto the actual computer to do AutoCAD work. And I think we were one of the first years that really moved on to embracing that technology. And where that kind of overlapped with my own interests, well, my brother is a computer programmer and he's a bit of a whiz computer programmer. He's always lost himself in trying to figure out how computers work, from the very first little green and black screen XT that we had secondhand in our house, through to what he's doing these days. But he pursued the whole computer thing, and me being the younger brother, I looked up to him and went, "Oh, what's he doing on the computer? And how does that match with my kind of, I had a little bit of an art interest, I had a little bit of a technical drawing interest, I had a little bit of, computer animation was quite popular at the time. A lot of computer animated movies and shows and commercials were coming out. And I'm like, oh, what is this? Who does this? Is this an actual job? And I think maybe if we didn't renovate the house, I would probably be more in the, technical drawing, drafting, or maybe even the computer animation field, rather than the engineering field.
So you can actually say you thank your parents for the career that you've taken then?
I think so, yeah.
In a literal sense.
In a literal sense, yeah.
That's excellent. Okay, so how different was university to high school? So if you were doing pen and paper, or pencil and paper in high school, and slowly starting to move into computer, when you went to university, what was that like?
University was completely computer-based. There wasn't any pen and paper anymore at the time. The main difference between uni and high school was really the self-motivating that you need to do. In high school, you're being fed everything, and you're being guided through your learning journey, really. And then when you're moving to uni, you need to pick something that interests you enough that motivates yourself, because lecturers don't care if you turn up. If you do your assignments or if you don't, there's no one riding your back, so to speak. So it's very easy to slack off. But you're just doing yourself an injustice if you're doing that. So it was the fact that I picked something which interested me, that gave me the motivation just to, keep going. And that's the main thing that I learned at uni, that you learn how to learn at uni.
Yep.
It doesn't really matter what technical content that they're trying to get into your head. It's the how to dig that information out from somewhere. How to learn how to break a big complex problem down into a whole bunch of little things, which 50% of those little things you already know how to answer, and the other 50% you know how to go and pursue the answer for.
So speaking about self-motivation, and obviously that's a huge learning curve when you get to university, because they don't really care if you do turn up to your lectures or not. You're not just a number, but they're not there to hold your hand through it. If you do it, you do it, and if you don't, you don't. So did you find that learning to have that self-motivation is something that has helped you now in your career?
Oh, absolutely. Yeah. And that's probably the biggest takeaway from uni, is learning that self-motivation, and being true to yourself, that if you're just doing something for the sake of doing something, it's probably not worth your time. Yeah, that's probably one of the biggest skills, to actually, know what things it's worth putting your time into.
Okay, so you're a structural engineer but completed a civil and construction engineering degree. Is there a difference between civil and structural engineering?
Oh, this is a hot topic. I like it. Okay, let's open up the can of worms. On paper, there's no difference between a civil and structural engineer. So I'm a Bachelor of Civil and Construction Engineering. The path is quite broad, though. So in the industry of civil engineering, you could be pursuing the civil aspects of it, meaning the roadworks or hydraulic work, so the stormwater drainage. Hydraulics also comes into there, so pipe layout, pressure valves, all that kind of stuff. Or you could be more on a geotechnical engineering, which still falls under the civil engineering banner, where you're doing site works, you're doing soil strengthening, so geofabrics and all sorts of things that you can do to change the properties of the ground that you're building on, or assessing the ground that you're building on, slope stabilities and all that kind of thing. Or you could go more into the structural part, where you're talking about things above ground. And even in the structural part, it's quite diverse, whether you're following more a residential type project path or more a commercial project path, or following, being specific with bridge designs or high-rise tower designs. Each one of those fields has a fairly unique set of skills. And in essence, they're all under the civil engineering banner. I call myself a structural engineer, just to let people know that I've focused my experience and my electives at uni more on the construction side, so the above ground works. Whereas other civil engineers pursued more of the road building and civil aspects, and they would call themselves more of a civil engineer.
So, from my understanding, from my research that I've done on engineering and just from working with some engineers, in my career, there's sort of six major branches of engineering. And then, from what I understand, is hundreds of subcategories underneath. So, how does one decide where to go and which path to take? And once you go down a sort of specialized route, are you stuck there?
How does one decide? And I think it's that deciding process is probably more a personal choice thing. So what interests you is generally what people decide on. Another thing that a lot of my friends used in their decision process was, what is the industry looking for at the moment? Where are the big projects, and what feels or sounds cool to them? Do they want to be involved in the very large infrastructure projects, or they want to be more of a hands-on engineer for the smaller stuff, more of a people's engineer, so to speak, for residential projects? So it's the initial choice of the engineering field is more of a personal interest. And from experience, probably 90% of the engineers don't actually work in that initial chosen field of engineering.
Well, that's interesting.
I've had an aeronautical engineer work for me in a structural field. I had a lot of friends who were mechanical engineers that had moved across into the structural field, and vice versa, structural engineers that had moved across into mechanical or robotics or mechatronic, or even mechatronic engineers that ended up being electrical engineers. So once you're in the workplace, the field that you end up in is kind of dependent on what you find, where the work is, and what interests you, and you can adjust that path. At the end of the day, the basic concept of engineer is you're applying science to real world problems, to solve them and give advice on how stuff should be done or how stuff works. So yeah, my journey was very largely kind of dictated by the work that I found at the time.
So it's probably a little bit different to a lot of other professional careers where you do get a lot of choice after you actually get your qualifications. But do you think there's a specific skill set that each branch or category of those branches require, or is it quite diverse that you can just sort of go from one to the other quite simply?
There is a unique set of skill sets with each. It depends how far across the tree of engineering fields you want to jump or end up jumping. Myself, as a civil or structural engineer, I don't have the skill sets to be a chemical engineer, for instance. I'd have to relearn chemistry a lot more than I know right now. Similarly, if I wanted to become an electrical engineer, there's a lot of laws that I'm unfamiliar with. I know basics of electrical stuff, but I don't really know all the ins and outs. So there are large gaps between the major fields of engineering. However, with engineering, there's kind of two areas that people tend to fall in. Either they become a very technical engineer, like a design engineer, or they become more of a project manager, where you're running jobs and you're managing people and you're organizing the run of a particular project. The project management side of things is fairly common skill sets amongst all engineering fields. The technical design aspects are the bits which require a little bit more specialization. So where I've said that a lot of people have diversified, they've either diversified technically within an adjacent kind of engineering field, so they've done a little small step into something that's related, or they've gone into more of the project management side and started running, as an electrical engineer, started running a big infrastructure project. Because the project management and people handling and resource handling skills that you learn are transferable.
And so where do you sit between the technical and the project management side of things?
Well, now that I've gone out on my own, I kind of have to sit across both, which was a nice new challenge. So my normal brain pattern, so to speak, is more than a technical role. I love my numbers and solving problems and being able to prove it numerically and also maybe physically with testing or whatever that might be. So I really enjoy that. But when you're on your own, you need to be able to do both. You need to be able to deal with people. You need to be able to set up contracts. You need to be able to make sure that time management and is on track and that budgets are on track and that you're making money.
So do you have a typical day in your life? Like, what's your typical day look like?
Typical day in my working life?
Yes.
Would be quite varied, actually. There are some days where it's completely design-based, where I turn up at my office and I look at a project that's currently on the go and I work my way through systematically figuring out whether the job works or not and what how strongly that it needs to be in order to stand up, to stay standing. Other days it's more quoting and people based, where I might be spending a lot of time in meetings or spending a lot of my time doing fee proposals, trying to win contracts, talking to people, talking to clients. So it really is a little bit of a reactive job in that sense, in what I'm doing at the moment. But that changes depending on where you're working. If you're part of a bigger team, your day might be a little bit more routine. If you're part of a large infrastructure project, your day might be a little bit more routine as well. You know what you need to get done for that day. Someone else does all the scheduling for you, and you just go and do your work. So it really depends where you end up working and what projects you're on.
So you've worked for both. You've worked for large firms, and now, as you said, you're out on your own. How do you find now that you've got to sort of go out and search for work and hunt for work and do that salesman side of things? How are you finding that as a balance between your technical ability and having to go out and be sort of customer facing and chasing down that work?
I've always enjoyed the challenge, so to speak. I've always recognized where in my career path I might have weaknesses, and then looked at how I could pursue those and improving those. So I wouldn't have gone out solo if I hadn't already dealt with chasing down work and customers and clients in my previous role. And I started my engineering career in a large multi-state business based in a national business. And I worked my way up from initially when I was a draftsperson, really, because they needed to teach me how things go together, through to design engineer, became a department manager for about 5-6 years, where I ran a team of about 28 people. So with that experience, I already took baby steps at learning how to work with people in my own team, and also how to kind of sell the product that we were producing to clients outside of our business. Obviously, in the larger company, you've got a lot of support. There's people that are tasked to go and chase a lot of the big projects. There's marketing teams, there's all that kind of thing. So that was one of the things which I needed to learn or take on board when I went solo, because you start wearing all hats, especially if you're completely solo. You have your marketing hat, you have your design hat, you have your and it's just kind of how I see it. You wear your different hats, and you need to make sure that you've got all of them in front of you. And every now and then, I haven't worn my marketing hat in a little while, so I need to pick that one up and put that one on, and then just do some things which help promote your work. So it is a nice challenge, because you're trying to balance getting the work done and also making sure that you've got work coming in for the future weeks coming ahead, so you don't have a quiet period. But yeah, that's why I did it, because I enjoy that challenge.
So do you think that that's helped you with your career, having to add in all those different aspects of business?
I think so, yeah. I think it's kind of a natural progression. I think if I would have sat in an office doing the same design day in, day out, like little cookie cutter designs, I would have probably gone crazy. So I like making sure my brain is still switched on, and that's basically a little, in my opinion, a bit of a natural progression, that you look at what else is next, what else is involved in this project. It's not just the design. There's a decision process that happens way before an engineer gets involved. So how can you influence that?
So you've obviously been through a lot of stages in your own career. What would be your advice to someone looking to getting into engineering, or somebody that has just graduated as an engineer, of how they can sort of move their career forward?
It's a really good question, and I think everyone's journey is going to be unique. One of the main bits of advice would be to never stop learning, and never close your eyes to opportunities that might present themselves. One of the guys that worked for me, this is actually the aeronautical engineer, I asked him why he wanted to do structural engineering if he had what to me sounded a much more interesting job, repairing and designing airplanes. And he said a good thing. He said that there was a particular incident in the aeronautical industry where a particular rotor in an airplane was worn out. So an engineer designed a new rotor for this propeller, and used the modern alloy as opposed to the old alloy that the plane originally used. And over a very short time, fatigue kicked in, and the new steel, that new alloy, actually fractured. Even though design-wise it was fully to spec, the actual combination of the chemistry and the actual metal meant that it was a lot more brittle. And the airplane fell and people died.
Wow.
And the reason he told this story was it opened up his eyes that even though you might be very good at your own field and the things that you have learned and you can control, there might also be variables that you don't even know about, that you don't even think about. So the design engineer on that particular job didn't do anything wrong, but he wasn't aware that what used to be called that particular steel these days under the same name is actually a different chemical composition. So it was a slight unawareness that caused a big incident. So the reason why my friend joined, or my colleague decided to do some structural engineering, is because he wanted to learn things outside of aeronautical engineering that might influence the work that he might need to do in the future, basically to broaden his experience, to look past those blinkers, so to speak. And I took that on board, and ever since that conversation, I went, he's right. There might be variables around you which, if you're following your own kind of path and knowledge and assumptions, you've never even questioned whether that's a variable to consider. So step back every now and then and go, what are the things that I don't know, or the things that I'm not aware of, and look into them and research them. So my curious mind has basically always has done that. It's kind of stepped back and gone, I wonder if there's something else that I might be missing here, and then just pursue it.
So speaking about sort of stepping back and taking a look at the things that you don't know, I know that as a professional engineer that you need to undertake a certain amount of continuing professional development hours, or CPD hours, or as it's known in sort of the professional world. How many do you need to complete every year as an engineer?
Yeah, that's true. When you need to 150 hours. The reason I'm kind of hesitant there is it depends why you're keeping up the CPD hours. So CPD hours are prescribed by Engineers Australia. Now, not every engineer needs to be a member of Engineers Australia, but if you are, they offer a lot of support. And also, when you're looking for a position, they acknowledge, or they verify that the degree that you've gained is transferable. So even if I were to work internationally, it's Engineers Australia that have accredited my university degree and said that it is within a certain standard, and therefore will be accepted if, for instance, if I were to work in the UK or the US. So for Engineers Australia, if you want to be a member with them, you need to maintain your CPD hours. So it's 150 hours, which seems like a lot, but that's spread over a 3-year period. So you might have some years where you've got more hours and some years where you've got less, as long as it averages to 150.
So what's your personal opinion on those CPD hours? Do you feel that they're beneficial, or do you sort of just think that they're just ticking the box and, being able to sort of, keep the membership up with Engineers Australia?
I think it's 100% beneficial. I think it's very easy for people to get comfortable in what they're doing and not to look at new technologies or new things that might be out there, or not broadening their learning horizon. So the CPD hours really force you to just get in touch with the engineering community or the academic community and learn some new courses, or do some management training, or just get on top of the latest and greatest in a particular field. What's the newest concrete technology that's out there? It's a science industry, and science always changes and evolves and improves. So the CPD, the concept of keeping up your professional development hours is to stay on top with the latest and greatest. So I think it's definitely a good thing.
So do you see that as sort of the minimum standard that you should do as an engineer? Do you put a lot of extra time in over and above both your hours that you put in the office, as well as those CPD hours, in learning new things and attending functions and conferences and things like that?
I think it comes in waves a bit. There's periods where I kind of get onto like a little bit of a conference bandwagon, and I go to a lot more little presentations, whether they're free or whether they're paid seminars. And then there's periods where work takes over, and I don't have too much spare time to put towards the personal development and professional development side. So it comes in waves, and that's why the 150 hours over 3 years average is quite beneficial, because there's some times where you do a lot of hours and other times where you don't, you get distracted, and and that's fine. That's fine. You just keep it up when you can.
Balance. Yeah,
it's a
so it's a
balance.
good balance. Yeah, excellent. Now, as I said before, you've worked for both large and small firms. How does the management differ in terms of the expectation and the workload that you have to put in?
With a large firm, there is a lot more redundancy in terms of you've got a lot of people. So if we're talking about an income stream, so every employee needs to be responsible for a certain amount of revenue. Some might be more productive, some might be less, and each person fluctuates in their productivity over time. But because you've got so many people in so many cities, there is a balance that happens. So you tend to have a lot of redundancy where if a project runs overtime, that another project somewhere else might be doing quite well. As long as not all projects run overtime, then generally the business will be ticking along. That buffer doesn't exist in a small business. So in a small business, if a project doesn't track well, then you can see the impact straight away. Or if a project is really productive, you get the benefit of that straight away as well. So that's, in terms of a business and workload sense, that's probably the biggest thing, that you don't have the buffer on that economy of scale. You don't have that ability to balance the books across many people.
And with the larger firms, is there a lot of pressure to meet those revenue targets, or is it a little bit more lax because you've got that redundancy built in with the other people that are in the firm as well?
That would depend on the business that you're working for. My experience is that quite often there is a bit of pressure to meet that deadline and to meet those targets. Quite early on, you're sheltered from the fact that the time is money. You're basically just told time. So you need to get this job done in this many hours. It's later on where, as your experience improves and you might get involved in quoting or that kind of thing, then you start associating the time and money aspect. So it really depends on the company, and it really depends on where you sit in the hierarchy, so to speak. And each company has different hierarchy. Quite often you might just be a design engineer. So here is your task, here's the hours that you're allowed to do it in. And if you go over those hours, we need to know why. And other places, it's here is a task, tell me how long you think that might take. And let's negotiate where and how you might produce that deliverable. So it really depends on which company that you're in, and their internal philosophy and their internal hierarchy.
So do you think it'd be beneficial for those sort of starting out to understand a bit more that the time is money? Or do you think that would sort of leave people a little bit jaded in the sense that what they're doing is based on money?
I'm not really sure it matters either way, to be honest. Most people are aware these days that time is money. Business is business. You need to produce deliverables and results in a certain amount of time. And the engineering industry, in a sense, is still very focused on the whole time is money thing. I think it might be starting to progress a little bit away from that these days, but very slowly. I think engineering, in a sense, is still a fairly old and deep-rooted profession of professionals, where time is money, rather than here is a product that you need to produce in however long it might take you, as long as it gets done. Yeah.
So obviously, being an engineer, you're very focused, you're very particular. How do you balance having to do a job within a certain amount of time with being 100% confident that what you're doing is the best amount of work that you can put out?
It's a good question. Actually, do you want to ask that again? I want to see if I can answer that a bit
Yeah,
better.
sure. So if you are, how do you sort of balance being able to give an output that you're satisfied with in the time restraints that you're given to do it in?
Any problem that comes across my desk probably has many, many different ways of approaching it. You could problem solve something on a very basic level, which won't take you too long, like basically a little back of notepad assumption, so to speak, or you put your best experience forward and go, well, I think the answer is going to be between there and there, and if it doesn't look like it's going to fail, then you don't need to spend more time on it. Other times you need to delve deeper and whittle down to a finer, a more accurate answer. And you need to pick your battles. So being able to split your project up into smaller bits and learning to attack the ones which need a little bit more attention, and I can't say skip over, but recognize that other aspects of the project aren't as critical, so you don't need to spend that much time on them. That's the art of engineering. And the term art of engineering is therefore used in that way because you can't run the numbers on everything. You need to break it down, whittle down the bits that are really important, get accurate on those, and recognize that the other parts are going to fall in place and don't need that much attention.
Because engineering is it's a form of science, but science is never exact, so there's always that bit of gray area in between. So is that sort of what you think with regards to sort of balancing that, where you know that there's that gray area, and that just because the numbers say something doesn't necessarily mean that that's going to be exactly how it happens in the field?
Yeah, you've completely hit the nail with a hammer there. You've got it spot on. Engineering, my understanding of the whole fundamental thing, right? So with all my experience and all my study, what it all comes down to is engineering in essence is this way of convincing people of an exact answer around a whole bunch of probability and statistics or a whole bunch of unknowns. So I'll go to my client and I'll say that beam 100% needs to be this size. And it's a very nice, comforting, definite solution, right? So people go, oh, yes, the engineer said the answer is that. Mm-hmm. But at the end of the day, what we're working with is a whole bunch of unknowns. So let's look at a building. I don't know how much weight is going to be carried by this building. There's codes and standards that say you need to carry a minimum of this much. But will the building ever actually carry that much? We don't know. And then we put a factor of safety on that to make sure that we don't ever exceed it. Then we go down to the material itself. There's design standards that say the steel needs to be at least this strong. But we've just said it there, that it needs to be at least this strong. So most of the time, the steel is going to be stronger. We don't want it to fail, so we're working with the lower limit. We're saying that all the bits of steel that we get out of the mills are stronger than this. But we work with that lowest number. So all of a sudden, we've got this, how much does it need to carry? We don't really know. How strong is it? Well, it's at least this strong, but it's probably going to be stronger. And at the end, we do the math and we calculate all the physics, and we get to this, it's at 100% spot on. Like we now know a definitive answer. But it's a definitive answer around a whole bunch of unknowns in the first place. So you never really have an exact answer, no matter what you do. So, and that's why it's an art of engineering. You need to recognize where your variability is, how much flexibility is there in the loads, how much flexibility is there in the strength, and how do the two combine, and what's your final answer? So yeah, it's a very interesting approach to engineering. It's this exact science in the mind of everyone, but and even as yourself as a graduate engineer, or when you're studying it, it's a very exact science around a whole bunch of variables and unknowns. So it's this nice little cloud of illusion around this gray space.
So there's obviously a lot of risk then around, engineering and being, the person that says that this is going to work, this is going to be safe. What cost is associated with that with regards to your insurances and any indemnity that you need to get for that?
Yeah, so there's a lot of insurances that engineers need. So if you're working for a big company, it's the company itself that has the insurances. And then if you're working on your own, or if you're the person that's actually signing off projects, you as the person need the insurances. Because no matter what you do, there's going to be risks. So even at times when you've done nothing wrong, but something does go wrong, then people are going to look for compensation. So you need to have yourself protected. So professional engineers have a public liability insurance as well as a professional indemnity insurance. One covers incidents that might affect or influence people or property outside of the job that you're currently doing. So it falls down onto the neighbor's property, for instance. And the other insurance is to protect your own professional work, so the work that you're involved with directly. So you've under-designed something, or the work that you've been involved in doesn't perform as expected, so it needs to be repaired or strengthened, then that insurance covers that side. So you kind of do you need both aspects, both the professional indemnity and the public liability.
And how much do you stress about the answers that you give people? Over time, do you sort of learn to go, no, I've got the confidence in myself that what I'm doing is right, and you don't have to worry about that as much? Because obviously being a structural engineer, the things that you are saying are going to stay up are supposed to stay up for a long time. So do you always have that in the back of your head, that what if something happens, or is that something that you can just design, move on and go, I've done absolutely everything I can do, I'm satisfied, and I don't really worry about that?
I'm not sure you can really worry about it too much, otherwise you go completely crazy. But at the same time, you need to be diligent enough to make sure that you've satisfied yourself, that you've done the best possible checks and balances in a particular structure. The other thing that gives structural engineers some confidence is the idea of redundancy, that there, in any structural system, there's more than one way a building will stay up or stay standing, that if something were to go wrong, it isn't a catastrophic failure, that it's a small failure that's recognizable to allow people to get out or to allow the problem to be fixed. So the worst thing that can happen is if there is no redundancy, and one little failure can lead to an entire catastrophe, and like a cable snapping causes the whole bridge to fall down. You need to make sure that no matter what you do, you always have a redundancy. You never fix something with one bolt. You always put two in there in case one of them fails. Just little things like that. And recognizing that that is what you're doing in your designs means that you have the confidence that if something unforeseen does happen that you didn't account for, that there's enough redundancy in the structure so it can be addressed before it becomes a big problem.
Okay, so obviously working in such a stressful environment, everybody has their outlet that they look to, whether it be their hobby or something that they thoroughly enjoy. Now, you've got something a little bit different that you do outside of work, and I had never even heard of it until a few weeks ago. So are you able to tell me what you do to relax outside of work?
I know what you're referring to, but I probably, in my own defense, have to say it's more of a friend's hobby or profession that I help out with. We've got close friends that are balloon artists. So to the point where their entire wedding was actually all made out of balloons. They built an entire enchanted forest, and all their bridesmaids' costumes and their own wedding dresses were all made out of balloons. So when they approached us that they were looking for volunteers, for instance, for that balloon build for their wedding, I jumped up at the opportunity and spent 2 days inflating and tying balloons and learning how to make giant flowers and trees and all sorts. Then when the same people came back and said, "Hey, we're doing an event up in the Monday markets, and we need someone to dress up as a giant balloon koala," I again went, "Yeah, why not? Let's act the fool, run around and be a giant balloon koala." So that's happened a couple of times, and why not, right? Like, you need to be a child and play around every now and then.
Absolutely. So do you think that gives you sort of your creative outlet from the day-to-day stresses of your job? Because it looks so fun. When I saw the video of you in that koala suit, and I hope that I can post that onto my website, um, I was in hysterics. It was so funny. So is that your way of just going, oh, and just letting your hair down?
Oh, absolutely. I think most of my hobbies are aimed at kind of balancing my brain. Um, very technical and stressful at work, and then my hobbies are far from, whether I indulge in some woodworking, making like a cabinet which I spend way too long sanding every corner on, or tinkering around in the garden. I've got like a carnivorous plant collection which I've had for quite a while, or spending way too much time making the perfect sandwich in the kitchen. People always laugh at me when I spend an hour to make a sandwich that takes me 5 minutes to eat. But they're my ways of turning my brain off and doing something different, and not thinking about work, and kind of being creative and trying something new. Because balance is what it's all about. You need to, in my opinion, have a little bit of both world in your life.
Absolutely. I have to agree with that. So what's next for Stefan, both professionally and personally? What's your next steps?
It's a good question. I never really know. I'm kind of one of these now brains. My plan is to continue working on my business. I started STS Structural about 1.5 years ago, and I'm at the point where I'm getting too busy for myself. I'm starting to wear myself down. So the next step professionally would probably be to get some help get a junior engineer or another engineer to come and help me out, and basically grow the business from a one-person operation to something a little bit more. And that gives me a little bit more spare time. And on the personal front, I don't know yet. I was hoping to do a little bit of traveling, but with the whole world situation these days, I think that's probably going to be more local than international. The future will tell. It's up in the air.
That's awesome. So I think I want to ask the most important question of today. What would you do differently if only you knew?
I'm not sure I would do much differently. It's an interesting answer, because quite often people would go, if I knew, that I would probably have not done this and not done that. But I think everything is part of the journey. Like, if I would have known how stressful things would have been, well, I kind of knew how they were going to be anyway. If I would have known that time is money and there's going to be a lot of time pressures in engineering, well, most professions are like that. So I've enjoyed my journey. I've been flexible and open enough to adjust to opportunities as they came along. So you never know. So even if only I knew, there would have still been curveballs that come in, because you never really know. So you just need to be flexible and adjustable.
That's a great answer. All right. So thank you so much for taking the time to chat with me today, Stefan. I really appreciate your insights, and I'm sure that any person out there that's looking into the engineering degree, or anyone that even works with engineers, will take this and have a little bit of an insight into, what you go through on a day-to-day basis. So thank you so much for your time.
Thanks, Christy. Yeah, thanks for having me. It's been fun to chat.
So if you want to know more about Stefan or STS Structural Engineering Consultancy, you can follow Stefan on LinkedIn or check out his bio on our website, ifonlyyouKnewpodcast.com.au. And I am going to twist Stefan's arm and hopefully have those images up of the koala balloon suit as well. So take a look at that.
Perfect. Yeah, thank you.
For more information about our guests or our show, visit ifonlyyouKnewpodcast.com.au.